Today, I will share with you information on the journey of the Cassini-Huygens mission to Saturn and its moons. The Cassini mission was a massive undertaking. From its sheer size, to the amount of distance it has traveled, to the amount of data it has gathered, everything about Cassini is big. Over its lifetime, the vehicle processed millions of commands from Earth, sent back hundreds of thousands of images, and traveled over 2 billion miles. The Cassini satellite was named after Jean-Dominique Cassini, the astronomer whose most notable achievements are the discovery of 4 of the moons of Saturn and also the discovery of the gaps between the outermost rings of Saturn. The Huygens lander, destined for the surface of Titan, was named after the astronomer who discovered Titan, Christian Huygens. The Cassini satellite was originally expected to orbit Saturn for about 4 years, however, it actually ended up completing 13 years of observations. The Huygens lander still sits today on the surface of Titan. All in all, it took Cassini a total of 7 years to reach Saturn, using 2 gravity assists from Venus, 1 from Earth, and a further gravity assist from Jupiter to manage to get to Saturn. During this time, Cassini took many detailed images of these planets, including Earth's moon and several asteroids. The Cassini spacecraft itself had many major components that made up that spacecraft package. Some of the most prominent are the propulsion system, the communication system, and the power system. The largest component by far is the Huygens lander itself. Cassini's movements are governed by the main engine on the bottom of the craft and several directional thrusters positioned throughout the structure. Its main engine is used for large changes in the orbit profile, delta V maneuvers or change in velocity, such as interplanetary changes. The directional thrusters adjust how the spacecraft is pointed in 3 dimensions, equivalent to the pitch, roll, and yaw used when talking about aircraft orientation. Cassini maintains communication with NASA's deep space networks via its radio wave subsystems as well as its antenna subsystem, which is made up of its high-gain and low-gain antennas. The high-gain antenna is the large dish that is noticeable in any figure of the spacecraft. For power, Spacecraft Cassini is powered by 3 radioisotope electric generators. These generators are run by plutonium dioxide, a radioactive fuel source material, which allows the spacecraft to run independently of any source of sunlight, removing the need for any solar panels. By far the most ambitious portion of the Cassini-Huygens mission was the landing of the Huygens probe on the surface of Titan. This was the first time a probe was ever landed in the outer solar system. Once landed, Huygens was able to take over 37,000 images and record a surface temperature for Titan of negative 290 degrees Fahrenheit. For the descent process, once the Huygens probe had exited the thickest part of Titan's atmosphere, it was time to deploy the Huygens descent control subsystem. This subsystem was comprised of 2 separate parachutes, the first being used to slow the vehicle down to Mach 0.6, and the second being somewhat similar, but it allowed a fairly rapid final phase of the descent due to the concerns about limited battery life. During the descent, many photos were taken by the lander as it moved towards the surface. Here you can see sample photos of drainage patterns on the surface of the moon, which is interesting because those drainage patterns are for flowing methane rather than water due to the temperature on the surface of Titan. Once landed, further photos arrived. In this case, here's a sample of the dry methane riverbed that the Huygens probe landed in. These are giving scientists a much better view of how this particular moon works in terms of its geology, etc. Here you see a source of all the references, both image and source material used for this presentation. Thank you very much.